BP Crucis is the most massive X-ray pair in the universe currently known to terrestrial science, consisting of a blue hypergiant and one of the most massive pulsars. In October 1970, a team of astrophysicists from the Massachusetts Institute of Technology, led by American-Dutch astrophysicist Walter Leeuwen, officially announced the discovery of 5 new X-ray sources using high-altitude balloons. Among the discoveries was an X-ray source located in the constellation Crux and identified with the blue variable hypergiant BP Crucis, located between 9,800 and 13,000 light-years away. Then, by analogy with the X-ray source Scorpio X1, already known to science, it was proposed that in the BP Crucis source the blue hypergiant has a compact companion nearby, with which it willingly shares its matter. A little later, thanks to more advanced observational tools, it became possible to understand that BP Crucis is a binary system consisting of a blue hypergiant and a long-period X-ray pulsar. The blue hypergiant in the BP Crucis pair is approximately 43 times more massive than our Sun and has a radius more than 70 times that of our central star. It is one of the most luminous stars in our galaxy, with an estimated bolometric luminosity of 470,000 solar luminosities and a surface temperature ranging from 16,000 to 18,000 Kelvin. The system's compact companion, in turn, is a neutron star, a type of so-called high-mass pulsar. Its mass ranges from 1.85 to 2.5 solar masses. This pulsar rotates on its axis every 685 seconds, which is quite slow for such objects. The pulsar orbits its more massive companion in an elongated orbit with a period of about 41.5 Earth days, and at the same time vigorously accretes matter from the hapless hypergiant onto itself, which, before falling onto the surface of the neutron star, forms a relatively wide accretion disk. In the immediate vicinity of the neutron star, it collapses as plasma movement across the magnetic field lines is greatly impeded. In this case, matter can no longer move in the plane of the disk. It moves along the field lines and falls onto the surface of the neutron star at its poles. This results in the formation of a so-called accretion column, much smaller in size than the star itself. Matter, striking its solid surface, heats up intensely and begins to emit X-rays. The X-ray pulsations are due to the accretion column alternately disappearing and reappearing due to the neutron star's rotation. Thus, we can observe a classic X-ray pulsar. As of early 2025, the BP Crucis X-ray pair has the highest combined mass of any such object currently known to humanity in the universe. Whether BP Crucis will retain its top spot in this ranking in the future will depend on further research in this area.